Well, hi everyone, and welcome back to Dad's Shed. What are we doing today? Well, over the last few hours I've been absolutely assaulting a medium-sized milling machine. If it was an animal, I'd be put in prison. What I've got here were a couple of pieces of steel plate. It's black material. It's 300 by 200 by 20 millimeters thick. And I've taken it down to just over 6 inches in width. And I've done that using a 4-inch side and face cutter, 3/32 thick, and I've effectively used it as a slitting saw. The reason I've done that is that I'm not quite getting what I want from that collet chuck. It's a Clarkson one, it's a very good one, it's 30 international taper and it's great. But I did notice when I put that cutter in there that it's oscillating. So after I did one side, I moved everything out of the way, put a gauge on it, and I'm getting about 0.2 to 0.3 of a mil movement on the end of the chuck. I've taken the chuck out, I've checked the bore here, and in 3 different places in the taper I'm getting 0 deviation. So that says to me, with that going round, even if the bore of this is at a slight angle, I would get some form of deviation, but I'm not. So that's running true and parallel. So it's the chuck, and it's giving me a slight wobble on everything. It's nothing I can't live with, but it's not right, and I'm going to have to look at a way of getting around it. But that's why I was using a side and face cutter rather than the slitting saw, in that it would actually take off both sides, give me a slightly wider cut than I was actually after, but only by about a 32nd of an inch. So I've taken it down. It's taken quite a while because of the wobble and the eccentric movement of the cutter. I didn't want to run it too fast, so I was running at 160 RPM. I was using the power feed on here, and 12 inches is only just within the capability of the Tom Senior. And it was taking about 8 minutes per cut. I was taking 3mm deep cuts, so that was 7 passes to take it through to full depth and cut the piece off. And there's some of the lumps that came off it. As you can see, they've come off quite nicely, and obviously that's given me a source of basically 20mm square stock. So what am I doing? What am I doing? Well, many of you may have seen some of my previous videos where I'm talking about a new vertical head for this milling machine. And I'm not going to go through that whys and the wherefores because it's all on previous videos, but this head will only do 500 RPM minimum, and it's not very good if you want to do larger work. So I'm making a new vertical head, and that's all going very well. However, I'll go and get one little piece. The spur gears that I've just cut are absolutely fine, and that that will go on to that shaft, and on the other end will be a bevel gear. And here's the bigger bevel gear. However, and you probably can't see this on the video, although I'm quite happy with my first ever bevel gear, it is not right. And the reason it isn't right is almost certainly down to the rather dodgy setup I had of the rotary table to get it at the angle I need. And I had it on an angle plate which isn't really big enough, so it's bolted at the top and trapped at the bottom, and it was generally rather nasty. So I want to remake that, but that means I actually want to set my rotary table at the right angle, and I've got no way of doing it. I can't set it across because this is too big, too fast to actually run the 10 dp cutter I'm using. So the only option is to make a sine plate. So I've got these two bits of 20mm. I'm going to do the bars on it at 10-inch centres, which makes it easy from Machinery Handbook to calculate how much packing I need to put in to get to the angle I need. And I can then use my digital protractor to get a rough estimate anyway. So, the next problem. These are going to be 12 inches by 6 inches, which means that the rotary table will sit on it and clamp down quite nicely. All well and good. So I can't go much narrower than 6 inches, otherwise I haven't got support across the back of the table, and I need 12 inches in length to give me the room for the pivot and the bar at 10-inch centres, and then to be able to bolt it down to the table and bolt that to it. How to hold it? Well, doing the outside edges is not a problem. I've bolted them down here, clamped it down to the table, cut them across. Setting up the others, all I've done to set it up is I've put a fairly thick piece of precision packing at the back here, moved the table back against the column. I know the column's square, I know my precision parallels are square, and that's put this in the right place, tapped it up against it, that's fine, and then turned it round and done the same again. I've also measured the widths and it's identical end to end, so I'm happy with that. It's slightly oversized by about 25 thou, which is great because I can now do a clean-up cut on the top. So to do the clean-up cut, what I'm going to do is take this off. I'll just put 3 holes in it, and they're tooling holes. They're 10mm diameter, which means that my 3/8 fixtures will go straight through. And so I'll put a big angle plate here, bolt that down to the table, bolt this to the front of the angle plate, going through those holes, and clamp it that way. Put a precision parallel underneath it to raise it up so the top's above the top of the angle plate, and then I'm going to use a 25mm carbide tipped cutter to just whiz along there, using the vertical head, and just take that down to dead size, and I'll do that on both. I bought myself a chamfer cutter, and the way I will do this is I'll then turn them through 90 degrees, mark up the 10-inch centres, and I'll do that using a spotting drill here using the DRO, and I'll do that in and out so I can get that square that up, and then I will use the horizontal travel, the x-axis, to move across and cut a small slot and then put a chamfer cutter through there to give me a 90-degree angle, which will then take some precision ground bars front and back. So I'll do that. That's got to happen on both of them, of course. So they're going to basically be, to start with, identical plates. Once they're all done, I'll clamp them together, drill through into the bars. The front bars will be modified, so the outer sides will have a reduced diameter going into a bore of the centre. They'll be clamped down and then drilled and tapped or drilled through, depending which particular bit it is. And that will then give me the ability to rotate it at the front and put the gauge blocks underneath the back. That's the plan. It's not a 5-minute job. It's something that came as a result of a need for the other project, and it's what Brandon at Intelligence and Machine will call a side project, but it's rather a major side project, and it's a project all of its own. But unfortunately the bevel gears, which is all I really need to do, are now on hold until I've got a way of holding them accurately at the angles I need. So that's what we're getting on with now. Okay, let's see about getting this little piece of work set up. Okay, no movement. I like that. Yeah, that's good. No movement from end to end. Again, doesn't make an awful lot of difference on what I'm doing, because all I'm going to do is do a skim along the edge, but it's a lot easier to set it up accurately first time, rather than suddenly realise you've been stupid and not done it at all. I'll lock this head off and I'll do all the adjustments on the knee, which gives me a much firmer grip on everything. Yeah, that's 25mm, so if I get that centered there and then lock the Y travel, and let's see where we go from here. Last bit of tapping down. Yeah, that's sitting down nicely, I think. Yeah. Right, sitting down on an inch parallel on the bottom. Just lifting up so it gives clearance here. I've got 3 clamps through the tooling holes, holding the plate back against the angle plate. The angle plate, as you saw, has been lined up using a dial indicator, so that's accurate. So I should now be able to just skim across the top here, take a light cut off, and this is I know this is about 25 thou oversize, so it shouldn't be a big issue. But I am going to end up using both the vertical head and the power on the main drive so that I can actually use the power feed to try and get a decent traverse across there. So let's just turn the power on. Now let me bring this up. Kiss any, there you go. Set 0. Okay, let's have another go. Let's see what we are in terms of size here. Thirteenth thou over. Zero. I'm not 100% certain that's sitting down all the way along. No, it doesn't seem to be sitting down at that end. Let's see that coat white. Let's just slacken off a shade. That's a bit better. That was looking as though it was just lifting a hair at the other end. That's it. That's a little bit better. Yes, that has dropped that down a shade. So let's take that up. Twelfth out. If that works out a thou oversize, then I will be quite happy with that. Nothing much to the surface finish. I think I need to put new tips on that. Okay, well that's taken that down. Let's give a quick check on the dimension at this end. Couple of thou out, and that is going to be about the same because it's taken almost nothing off of that end. So obviously it was very slightly out of kilter. Do I go up and take 5 thou off? I think that might be a good move. So where we are now, the two plates have been skimmed top and bottom, and they are within half a thou of parallel, which is about as close as I can get it on this machine. And what I'm doing now is I'm using 2 of the tooling holes in the top to clamp it down to the table. I've got small parallels underneath to hold it off the tabletop, and I've just put a spotting drill into this end, and I've spotted the hole. I'm then going to drill through 10mm. Then we'll go back then to a milling cutter, and I'll mill a recess that will enable me to put a hold down bolt nut on the top. So then I'll be able to do a skim cut along the top to try and get the top flat. I'll then flip it over and do the same the other side. I haven't worked out how I'm going to do the other side yet, because once I've actually got this bolted down, then I'm a bit stuck. But there will be a way, no doubt. So that's where I'm doing at the moment. So it's going to be a very simple job. I've spotted it, changed this over for a 10mm drill through, and then put a hole in, a recess in there, which is somewhat over 21mm, so about 25mm. Just mill in there, and I'll probably use my 25mm carbide bit and take it down. This is 20mm, so I'll take it down about half height, so I've got 10mm on there. So let's crack on with that. Let's go and find a drill bit. This is where machines like this have minor issues. Certainly they're not a production machine, and something like a Bridgeport or an equivalent will have a spindle lock. This doesn't, which means I have to use a spanner on it every single time I want to change a tool. I've had the good fortune to use Bridgeport's XYZs and some much heavier duty mills, and when you come back to something of this size, you suddenly realise what you're missing. But no, having said that, this is a very, very nice milling machine. Right, let's be a good boy. I'll swap my reading glasses, or my normal glasses I should say, for my safety glasses. I have had a couple of comments about the eye patch that you will see me wearing in a number of videos, and the reason for that is quite simple. My left eye doesn't work. It's nothing to do with machining, but it, from time to time, if I don't have it covered, it tends to give me a thumping headache. So rather than being a miserable old what's it on my own, I try and avoid being a miserable old what's-it with a thumping headache as well. Okay, a little bit done. Take that out of cut for the moment. And if I can find my littlest spanner, put that up there. I've got dead stop on here, so I'll just move that. I'm going to need to make a couple more stops for this. When I moved the last time, the senior stop block that knocks off the power feed was missing, so I don't know where that disappeared to en route, but it's a bit of a nuisance not having it. Okay, that was 100, so let's take this up to 120. So that's cutting through quite nicely. Taking in 1 inch so it centres over the hole that I've previously drilled. I'll do the same the other end, and that will then allow me to get the whole thing clamped down later. Well, welcome back into Dad's shed, briefly for the moment. As you can tell, I've got my shop coat on and done up, so it must be summer in the UK. And it is, it's the beginning of June. What am I doing here? Well, I've machined out the pockets at the end here to take hold down bolts. And before I move anything, I'm going to put 2 cuts across here at 9-inch centres, because I've measured this up. I can't really do it at 10-inch centres, but as I'm just multiplying on the sine, it doesn't matter. So I'm going to use 9-inch centres. But before I do anything else, I can't do the full width on this machine in this setup. I can only take it from about there to there. So what I'm going to do, I'm using a small 3-flue end mill, or slot drill, whichever way you want to term this particular thing. And I'm then going to machine across at 9-inch centres both sides, that end and at this end, as far as I can. So that will be about 3/4 of the width of the machine. What I'm then going to do is swivel it round, set up again, and I'll use the slot I'm milling to set up square to the column, and then I can mill across. Then I can use my chamfer bit to cut the chamfer in there to sit the bars in. So all I'm going to do, I'm literally just going to mill across there. I'll take it down probably about 1/4 inch. Because all I need is the reference face on the top. And I think I will speed this up a little bit with a small end mill in there. Because at the moment it's on 900, I'll take that up to 1600. That'll give me a better cutting speed for this size end mill. I suppose I could take it all the way up to 2.3, but I think I'll play a little bit safe on that. And I'll just take this up to 16. That's that and that. That can go back in. If I can get it in. Yeah, there you go. Give that a push. Give that a tighten. Put that down there. That back on. And then I'll take this up. I'll take that up to about there. And then I'll do any adjustments on the down feed on the head. So I'll go there. I zero that off. And of course, this being the senior S head, it has a slightly strange graduation on there, in that a fool's turn is not 125 thou you might expect, but it's 130. So it needs a bit of mental gymnastics when you come to going above that. That's as far as it will go that side, because it's now coming up against the nose of the INT30 spindle. So I'll put a little bit more cut on there. Let's take it back the other way. Great, smack on where I wanted it to be. Well, welcome back to the shed. Just one small point that some of you may have noticed. I seem to be suffering from an infestation of rubber bath ducks. They seem to be popping up everywhere. Obviously the force field around the shed has not kept the wife out, with the result that I am finding rubber ducks of various sizes just about everywhere. Yeah. Anyway, what are we here doing now? Well, I've done the ends and 2 slots in this piece. I'm now setting it up 90 degrees round. Now this is the master side. It's the side that I put against there and I've machined against. This side is almost totally parallel with it, to within half a thou, but I don't want to try and get it to 0, because if I try and get that side to 0 to match this side, I know I'm going to foul it up. So half a thou I can live with, but that does mean that this is my master reference face. So what I'm doing at the moment is I've put this on here, it's clamped down onto parallels. I've got that bolt at the end there done up, and that clamp is loosely tightened, and I've just been gently using a soft faced mallet, been tapping it across, and with my dial gauge on here I've now got to the point where it is moving the full travel that I've got on here until it actually touches that piece there, with no deviation at all. So I'm quite happy with that. It's going backwards and forwards and it's not moving. The reason it moved is that this is very slightly higher here and it just caught the bottom of the gauge mount. So I'm happy that that is at 90 degrees to the ways. So they will now be, as they were the other way, parallel to the travel of the table. So I can now look to extend those, and then I'll put the V groove in to take the 1/2 inch round ground bar that I've got that will make the reference points for the sine table. Right, let's move this out of the way, and magically this will all disappear in just a moment or two. Right, so just clear out the swarf from the slot. Take it up another 20 thou. Brush most of the swarf out. and come along with the coolant and just use fairly heavy squirt just to wash any more out, because the one thing that these small cutters absolutely hate is getting bound up with swarf in the slot, and then they break. And although they're small, small doesn't mean inexpensive. In fact, the smaller in a way, the more they cost. So I'm just doing the best I can to keep these cuts light, and speed up, and wash the swarf out when it gets to the end of the cut. So all this is now is just 10 passes at 20,000, sorry, 12 passes at 20,000 and one at 10,000 to get me down to the depth I want of 1/4 inch. So I'll do the rest of this off camera, because it really is just repeat, repeat, repeat. And then the next bit you've already seen, so I won't do that. Once I've got these two sorted out, then we'll get on to the more interesting part, which is getting them skimmed and fitted together, so that I can then start doing the pivots and everything else. So we'll come back to that in a little while, and I'll just carry on boring myself doing this. Excuse any scuffling noises outside, it's the children finding their way to the pool. This video is going to be a lot longer than I thought it was going to be, so I'm cutting it to 3 parts. I've cut it now, where we've got to the point where we are cutting the cross slots ready to make them into V's, and that will be in the next section, and that is getting this thing built. And a number of small changes were made in the design on the way, like 9-inch centres between the ground bars, because there's not quite enough room to really do it with 10. The hold down bolts will get in the way and everything, and I can't make this more than 12 inches long. So that's the first part done. I hope you've enjoyed it. It's been a bit long-winded, I think, in places, but I'm trying to explain the setups I'm using on this machine to try and do work that this machine really isn't designed to do. I've got a small machine doing big work on it. So I hope you found it interesting. Look forward to finishing the editing of parts 2 and part 3, where part 3 I actually add some other bits in which I suddenly realised would make it a lot more usable. So part 1 is done. Part 2 is coming up, which will be basically getting the rest of this in a situation where it could be used, and then we'll see where we go from there. As I say, I hope you've enjoyed it. Please like and subscribe if you have, and give me a thumbs up. See you later in Dad's shed.